This is chapter 9, second video. From this video, I would like to discuss 9.2, explore the top-down and stepwise refinement methodologies in solving problems. The content is modularization, top-down design and stepwise refinement, and structure chart. The outcomes are uses stepwise refinement methodology to solve problems, those structure charts to illustrate the solution for a system. Let's go to the today lesson. Concept of modularization. One of the most important concepts of programming is the ability to group some lines of code into a unit that can be included in our program. The original wording for this was a subprogram. Other names include macro, subroutine, procedure, module, and function. In later lessons, we are going to identify how to write the function, call function, passing parameters likewise. Then in Python program, we identify using functions, then the subprograms. It is very helpful to continue our solving problems. Then we are going to use the term function for that is what they are called in most of the predominant programming languages of today. Functions are important because they allow us to take large, complicated programs and to divide them into smaller, manageable pieces. Because the function is a small piece of the overall program, we can concentrate on what we want it to do and test it to make sure it works properly. Generally, functions fall into two categories: program control, and another thing is specific tasks. Program control. Functions used to simply subdivide and control the program. These functions are unique to the program being written. Other programs may use similar functions, maybe even functions with the same name, but the content of the functions are almost always very different. Another one is specific tasks. Functions designed to be used with the several programs. These functions perform a specific tasks and thus are usable in many different programs. Because the other programs also need to do the specific tasks. Specific task functions are sometimes referred to as building blocks. Because they are already coded and tested, we can use them in confidence to more efficiently write a large program. The main program must establish the existence of functions and used in that program depending on the programming language. There is a formal way to define a function, call a function, declare a function. In later lessons, we write some functions, then define functions, call functions, and declare function. The modularization is very helpful to prevent code reusability. Then code rewriting prevent by modularization. A problem can be simple or complex. According to its nature, it is rather difficult to perceive and understand complex problems when compared with a simple problem. It is essential to understand a problem thoroughly before going to solve it, so it will be easier to find solution to complex problem after decomposing it into small sub-problems. Then our main intention is to solve problems. Then we are discussing about solve problems with computer programming. In these situations, we have to identify problems and its sub-problems. It is very helpful to clearly predict the solution with computer language. So as example, we get this kind of figure with the several shapes and colors. Then we decompose them according to the shapes and according to the background color. Then it is helpful to understand what was there, and to sub-problems can be helpful to a great solution. Advantages of using modular programming approach. Ease of use. If I describe, this approach allows simplicity as rather than focusing on the entire thousand and millions of lines code in one go. We can access it in the form of modules. This allows is in debugging the code and prone to less error, as each module is to be tested independently. Testing is fast and more robust. Then, when we doing a job as a software engineering, we can write identified subprograms, subfunctions. It is help to identify the solution simplicity, and when we are going to testing those problems, those functions, it is more easy. Reusability. Then when we write common functions, we can call them in another places. It is prevent code rewriting. So code reusability is very important. It allows the user to reuse the functionality with the different interfaces without typing the whole program again. Thousands of line codes, some programs can be, and the same functions, some same content will be used in different places. If we can separate them as a subproblems in addition to if functions, it is helpful improve the code reusability. Ease of maintenance. It helps in less collisions at the time of working on modules, helping a team helping a team to work with proper collaborations while working on a large application. Modules are smaller and have lower level of complexity, so they are easy to understand. As an example, if we get new developer join for a company, there are many programs, many codes in thousands of lines, but he can identify if there are many functions separated, then he can easily understand the code and maintain and test likewise. Therefore, at modularization, the sub-programming is very important. Then we can identify two approaches for this, top-down and structure chart. First one is top-down design and stepwise refinement. Top-down design involves looking at the whole task and breaking it down into smaller, more manageable sub-problems which are easier to solve. These sub-problems can be divided even further into smaller steps. This is called stepwise refinement. Stepwise refinement means then top-down design stepwise refinement, main problems there. It is divided to sub-problems. Then it can be further divided to sub-problems. As an example, we got this quarantine COVID period. The whole country suffer from COVID. In that situation, government committee are working with many people. They are separating the authorities for divided separate parties. Then the ground level, the patient can identify with likewise. Then 25 district can identify patients and hospitals likewise. Then it is more manageable, dividing the whole problem into sub-problems and controlling. It is more manageable likewise. The structure chart. Second one, we are going to discuss about structure chart. The structure chart, module chart, hierarchical chart is a graphical depiction of the decomposition of a problem. It is tool to aid in software design. It is particularly helpful on large problems. A structure chart illustrates the partitioning of a problem into sub-problems and shows the hierarchical relationships among the parts. A classic organization chart for a company is an example of a structure chart. Have you gone to the RMV for getting some license? In that situation, you can see we have to go some different counters to collect our driving license. Then it has the organizational departments. So we have to move from some counters to another counters for complete our tasks. Likewise, they can be identified organizational separations to improve the solutions to provide some problems. Likewise, that structure chart can be applied for in our computer programming also. This is some example for the email login. Enter login details as this example illustrate as a structure chart how login to email and sending email. This is the email process. Enter login details, view mails, verify login details, compose in database, view messages, compose messages, send messages. There isn't a hierarchical level, but there is a separate components with interconnected for their dependencies. This is the structure chart. We have covered modularization, top-down approach, and structure chart. Let's discuss 9.3 in our next video. Thank you.